Hello, welcome. So for this problem, it is the insert interval. Basically, there's no difference from merge interval. We just need to put the new interval inside the intervals, and then we're gonna solve the problem similar as merge intervals. So I'm gonna use two methods. So the first one is greedy, and the second method is gonna be the sweep line. And for the greedy idea, we just put all the intervals inside, and we're gonna sort it. And after sorting, so for example, we just need to, this is the interval, this is another one, and this is another one. And after sorting, we just need to put all the intervals inside the result, this one and this one, and it should be okay. So yeah, let me just finish the greedy idea because this is straightforward. Now let me just start coding. So first of all, we want to put it inside. So interval, we want to append the new interval, and after that we're gonna sort it, and the length of the interval gonna be n. Now we want to prepare a start and add variable, because basically for each of the iteration we want to put the start and add tuple inside of a result. So I'm going to prepare a start and end. It's going to be the intervals 0, and I'm going to prepare a result because I want to put every interval inside my result after merge. Yeah. Now let's just finish the merge interval operation. So for I in range for the second interval 1 to n. So I'm going to prepare a start and add precision for my intervals I. Now I want to check if this add precision is more than the start precision. So this means there is a possible result, and I want to put it inside. Basically, it is the start and end. Yeah. So after I put it inside, I should update with the new start precision. So if I put it inside, so this means my start precision would be updated with the new start precision, so it's going to be S, because I've already finished the previous ones, and so for example this is the previous ones, and I need to start the new one. If I were to start the new one, I need to finish the previous ones, so this is the start and end. So this is my new start, it should be equal to this value, and it is S, so the start should equal to S. But no matter if I were to compare if it is more than that or less than or equal, I have to update the maximum precision of the end. So this end is going to be compared with this E. It's going to be the end precision. So if we finish all of them, for this kind of solution, there will always be another one left. Yeah, because according to this kind of calculation, so what about here? If this is and for example, while we are checking this start, so if this start is more than the end, we put everything inside, but that is the everything about the previous ones, but we didn't put this one inside. So this means finally we need to put it inside the result. So it's going to be the start and end, and I found a typo here. So basically from here it should be the start precision should be more than the end. Yeah, and this is my new start precision. It should be more than the end, and then I want to put the start and end inside. Yeah. Finally, I need to return the final result. Let me just run it to check if it works. As you can see, it works, and let me submit it. So the time complexity for this kind of solution is n log n time, because here is a sorting. Now we want to use another method. Basically the time complexity would be the same, but this method is a little bit advanced, and we're going to call it sweep line. The sweep line method is similar, but the idea is that we just need to record the start and the end precision. It is similar to difference array. We just need to sweep the start precision and the end precision. So for example, I will just use this example. So for here, if I find a start precision, I'm going to have a counter, it's going to be +1. If I find a start precision, I'm going to +1. So this means at precision, it's going to be 2. Here is the end precision, it's going to be -1. It means at this precision, it's going to be 1. So it means at this position it's going to be 0 because this is another add position. But while I'm find 0, I want to put the start and add inside my result array. So I have a possible result. And then I'm going to continue to check. If here the count would plus 1, and while it goes to here, the count would minus 1, and the counter becomes 0, and I want to put the start and end inside my result. So this is going to be my final solution for the sweep line method. So for this problem, while we are using the sweep line, it should be an easy problem. But actually the sweep line can solve too many difficult problems. Now let's just try to use this kind of method to solve the problem. First of all, we want to put it inside the intervals for the new interval. Now we want to prepare an event array. Yeah, let me use events. And for any start and add time or positions inside the intervals, I want to put it inside the events. So events should append the start position with -1. So this is just according to the problem, because according to the problem, so for this example, if I have 1, 4 and 4, 5, it will be merged together. It will become 1, 5. So this is why I should always sorted the start position should always first. So this means I should first finish the start with this 4. Yeah, this means that the end position will always come first. So this 4 for the end position. So basically inside it is 4 minus 1. It always comes first, and then I will have a 4 with a positive 1. So this is why, because it should always finish the end position, and then I will start a new position. So this is just according to the question. And for the end position, I just need to append the end position with positive 1. And after that, I need to sort the events. After sorting, I want to prepare a start and add variable. So for the start, I want to set it to negative infinity, because I want to check the maximum value of the start. Let me think about it. So I think I need to check the minimum value of the start. So it's going to be positive infinity, and the add position is going to be the negative infinity, because I want to check the maximum value of the add position. And I want to prepare a result array. Now I want to check the event array. So for any value x and a sign inside the event array, I want to check this sign. If this is a -1, this means this is my start position. So I have a count should plus equal to 1. So this means I need to define a count starting from 0. And let me first finish the basic template. So else the count should -1. So now I want to check if this is sign, if the count, so if this count equal to 0, this means I need to put a solution inside my result, and it's going to be the start and end. Finally, I just need to return the result. Now I want to check about here, because definitely I didn't update the start and end. So up to here, if this is psi equal to -1, this means this dot, this point is a start. So if it is a start, I want to update the start. So the start would be updated to the maximum of the start with this x. And similarly for the end, so the end is going to be the maximum of the end with this x, and the start should be the minimum, because I set to be infinity, and for each of the position I should start with this dot. Before that is infinity. Now I want to check this position. So for example, for this position, so for here I need to check the minimum of start with this value. I think it should be okay, because the start position should always be at the left, and the right position can be bigger and bigger to the right. Yeah, so that is why the right is going to be, the end position is going to be the maximum, and the start position is going to be the minimum. So here, if I find a result, I need to reset the start position to the infinity. So this is going to be the entire code. Now let me try to run it. As you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed, and this is a more advanced way of solving the problem, so it is called sweep line. Thank you for watching. See you next time.